Hi, I'm starting the second chapter in this course, the chapter on graphs and functions. And the first section is on rectangular coordinates and graphs. So this is going to cover in two parts, in two videos. I'm doing today the first, in this video, I'm doing the first part. And in the next video, I'm going to finish this section. Okay, so I'm going to read some information from the book about ordered pairs. Okay, the idea of pairing one quantity with another is often encountered in everyday life. Like a numerical scores in a mathematics course is paired with a corresponding letter grade. In our class policy, we have that between 90 and 100 is an A, between 80 and 89 is a B, and so on. The number of gallons of gas pumped into a tank is paired with the amount of money needed to purchase it. And you have the price per gallon. Or expense categories like the table you see on the left are paired with dollars spent by the average American household in 2013. So pairs of related quantities, such as 96, determine a grade of A, 3 gallons of gas costing $10.50, or a 2013 spending on food of 8,506 can be expressed as ordered pairs. So an ordered pair consists of two components written inside parentheses. In mathematics, we're more often interested in ordered pairs whose components are numbers. The ordered pairs A, B, and C, D are equal provided that A equals B, or that A equals C and B equals D. And we have been using a similar notation for intervals, but from the context we will know whether we are working with intervals or with ordered pairs. Notation such as 2, 4 is used to show an interval on a number line, and the same notation is used to indicate an ordered pair of numbers. The intended use is usually clear from the context of the discussion. Okay, so we're going to start with the rectangular coordinate system. So this works as follows. When we did inequalities, I mentioned the real number line. So instead of one number line, we're going to have two real number lines. So two real number lines intersecting at right angles form the rectangular coordinate system. Also known as Cartesian plane. It's called Cartesian because it was named after the French philosopher and mathematician René Descartes. Okay, so this is what the rectangular coordinate system looks like. We have two number lines that intersect at right angles. And the point of intersection is going to be the 0 on each number line. So they intersect at 0 of each line. And then we have each point of the number line. The last one is at -4. And the number lines, the horizontal number line is going to be called the x-axis. And the vertical number line is going to be called the y-axis. So they intersect at 0 of each number line. And that point is also important. This is called the origin. By the way, these are arrow tips. Okay, the point of intersection is called the origin. The point of intersection of the axis is called the origin. And the two axes divide the plane into 4 parts called quadrants. Into 4 parts or regions called quadrants. If you take MS 111, that is pre-calculus, that's going to be especially important, the quadrants. Okay, so you have the coordinate system. You have the rectangular coordinate system. You have the x-axis and the y-axis. So the axis divide the rectangular coordinate system into 4 regions or quadrants. The one on the top right is the first quadrant or quadrant 1. And from there, they go counterclockwise. So this quadrant 1, top left is quadrant 2 or the second quadrant. Bottom left is the third quadrant. Remember this going counterclockwise. And bottom right is the fourth quadrant. Okay, so a point on the coordinate system will be determined by the position on each number line, determined by each number line. Okay, so again, we have the coordinate system and pick a point xy. So some point. So you're going to have that point corresponds to an x coordinate and to a y coordinate, where x, the vertical position or the horizontal position is going to be determined by the directed distance. I'm going to put this on top. So that's going to be the directed distance. And the distance from 0 to the y coordinate. So you have the coordinates of a point. So each point, and the point is going to be xy. I'm going to do this with a different color. So each point on the plane corresponds to an ordered pair xy. each point on the plane corresponds to an ordered pair xy. All real numbers x and y call the coordinates of the point. Okay, so some examples of points are going to be the following. Okay, so some points are going to be, one example of a point can be the point 2, 3. So we have the point 2, 3. Determined by 2 and 3. Another point could be 3, 0. So the position on the x-axis is 3, on the y-axis is 0. And a few more. Negative 1, 2 is another example. A few more, negative 2, negative 3. Where both coordinates are negative. And one more is 4, negative 2. Okay, now do one more on the y-axis. We could have something like, let's say 0, negative 4. So those are examples of points on the rectangular coordinate system. Okay, so we're going to, I'm going to show you two formulas, how to find the distance between 2 points on the plane, and how to find the midpoint of a line segment joining 2 points. So we're going to do first the distance formula. The idea comes from the Pythagorean theorem, which I mentioned in the last chapter. You have 2 legs of a right triangle and the hypotenuse, and they are related by the equation a squared plus b squared equals c squared. Okay, so let's say we want to find the distance between 2 points, P and R. The points are again, P, that we're going to call x1, y1. I'm just going to write them. X1, y1. And Q, or the book is calling them R, so I'm just going to call them R, x2, y2. So let's say we have 2 points. some point x1, y1. And another point x2, y2. Okay, so the coordinates are going to be x1, y1, or x1, x2. Those are the x coordinates, and the y coordinates are y1, y2. And we want to know the distance. So this distance, we're going to call it d. D of p comma r. So let p denote the distance between p and r. Okay, trying to type. Okay, there it is. So let. Okay. So let p of or let d of p comma r denote the distance between the points p and r. So this is what we know from the Pythagorean theorem. We're going to form a right triangle. So a right triangle with dimensions d of p comma r, and the legs are going to be the measure of the horizontal leg is going to be, so this distance is x2 minus x1, and this distance is y2 minus y1. So the distance from 0 to y2 minus the distance from 0 to y1, and the distance from 0 to x2 minus the distance from 0 to x1. So the Pythagorean equation says that the square of the hypotenuse, in this case, the hypotenuse is the distance between P and R, is the sum of the squares of the legs, which are x2 minus x1 squared plus y2 minus y1 squared. And the distance formula will be the following. Take the square root on both sides, and the distance between the points P and R is going to be the square root of x2 minus xy minus x1 squared plus y2 minus y1 squared. And I will copy the formula from the book. That's on page 185. There it is. So let me copy this. That's on page 185. Suppose that P, x1, y1, and R, x2, y2, are 2 points in a coordinate plane. The distance between P and R, written D of P comma R, is given by the following formula. The one that I just wrote. The distance between P and R is the square root of x2 minus x1 squared plus y2 minus y1 squared. So we're doing some examples. We're going to do some examples. Example 1. Determine, or not determine, find the distance between the points P, negative 3,4, and the Q, 1,6. We're going to use the distance formula to find the distance between the points without even graphing the points. Okay, so P, we're going to call the values x1, y1. And Q, x2, y2. From the distance formula, we know that the distance between P and Q it's x2 minus x1. So this is 1 minus negative 3 squared plus 6 minus 4 squared. But 1 minus negative 3 is 1 plus 3. So this is the square root of 1 plus 3 squared plus 2 squared. 1 plus 3 squared is 4 squared. 2 squared is 4. So that's the square root of 16 plus 4, or the square root of 20. So if the square root is an integer, we're going to simplify it. This one is square root of 20. We can reduce it because the square root of 20 is the same as square root of 4 times 5. Or square root of 4 times square root of 5, which is 2 square root of 5. So at the end, the distance is 2 square root of 5. Square root of 20 or 2 square root of 5, both are correct. Okay, this one is from the book, and you're going to have problems like this on the homework. That's on page 193, number 24. We will determine whether the points are the vertices of a right triangle. So we're going to find the distances of the points 2 by 2. And we're going to see if they satisfy the Pythagorean theorem. This is on page 193. Okay, so let's call the points P, Q, and R. So we're going to find the distance from P to Q, the distance from P to R, and the distance from Q to R. The distances are going to be the sides of a triangle. And we're going to check whether they satisfy the Pythagorean theorem. But we have something like this. Just to have an idea, we have mainly negative numbers. Then we have the x values. And we have 3 points. We have the point -2, -8. So that's the point P. A point 0, -4. This is the point Q. And the point R is -4, -7. Okay, so the 3 points form a triangle. first sight, it looks like a right triangle, but we need to verify that. We need to make sure that this is indeed a right triangle. I just didn't do it straight. Okay, so let's find the distance from P to Q. Okay, the distance from P to Q, that's going to be the square root of x2 minus x1. So this is one. This is 0 minus -2 squared plus -4 minus -8 squared. Zero minus -2 is 2 squared. And 4 minus -8 is going to be -4 plus 8, so that's going to be 4 squared. This is 4 plus 16, or the square root of 20. For now, I'm just going to leave it like that, a square root of 20. Because I'm going to square the sides to verify that they are indeed the vertices of a right triangle. Next point, or next distance, is the distance from Q to R. This is the square root of. So x2 minus x1, that's going to be -4 minus 0 squared plus -7 minus -4 squared. Okay, so -4 squared is going to be 16. That's the square root of 16. And -7 minus -4 is going to be -3. So -3 squared is going to be 9. That's the square root of 25, or simplified. And the last one is the distance between P and R. So that's going to be -4 minus -2. That's the square root of -4 minus -2. Plus the distance, plus -7 minus -8. So that's the square root of -4 minus -2 is -2 squared. So that's going to be 4. And -2 minus -8 is 1. So that's going to be 1 squared, which is 1, or the square root of 5. Okay, so we're going to verify. You can see that this is the longest side. So this is possibly the hypotenuse. Okay, so this side is the longest one. So let's verify that this is indeed, that the points are indeed the vertices of a right triangle. Phi squared, we want this to be equal to the square root of phi squared plus the square root of 20 squared, or in the order I did it, that's the square root of 20 squared plus the square root of phi squared. Phi squared is 25. Square root of 20 squared is 20. And square root of 5 squared is 5. So we have that 25 equals 25. So this is true. And the answer is that yes. The points are indeed the vertices of a right triangle. Okay, so the first formula was the distance formula, and the next formula is the midpoint formula. So this is going to let us find the midpoint of the line segment joining 2 points. So let's say we have 2 points, x1, y1. And a point x2, y2. Or a point, we're going to call it Q. Q, a point with coordinates x2, y2. And then take the line segment, joining the points. So the point that is midway is going to be the midpoint. So this point is the midpoint. And the coordinates are going to be, the x coordinate is going to be the average of x1 and x2. So that's x1 plus x2 over 2. And the y coordinate is the average of y1 and y2. But I'm going to copy the formula. The coordinates of the midpoint M of the line segment with endpoints P, x1, y1, and Q, x2, y2 are given by the following. So the midpoint M is going to be x1 plus x2 over 2. That's the x coordinate. And the y coordinate is y1 plus y2 over 2. We're going to use the formula to find the coordinates of the midpoint M of the line segment with endpoints negative 7,4, negative 7, negative 4, and 10, 2. So the points have coordinates x1, y1, and x2, y2. The midpoint M is going to be x1 plus x2. So that's negative 7 plus 10 over 2. Comma, negative 4 plus 2 over 2. Negative 7 plus 10 is 3. We're going to keep this as a fraction. And negative 4 plus 2 is negative 2. We can simplify this as negative 1. So at the end, the midpoint, the coordinates of the midpoint are 3/2 and negative 1. So now let's suppose that we know one of the endpoints and we know the midpoint, and we want to find the other point. We can still do that. If we want to find the coordinates of the other endpoint, Q of the line segment with one endpoint, -2,5, and midpoint 0, -3. We're going to use the midpoint formula. We're going to let xy represent the coordinates of Q. So let xy represent the coordinates of Q. From the midpoint formula, I know that x minus 2 over 2 is 0, and y plus 5 over 2 is -3. So these are linear equations that we learn how to solve. X minus 2 over 2 is 0. Only if x minus 2 is 0. Only if the numerator is 0. So the x coordinate is 2. And then we can multiply 2 on both sides. So y plus 5 is -3 times 2, so that's -6. Add 5 to both sides, or subtract 5 from both sides, and y is -11. So the coordinates of endpoint Q are 2, -11. And I will finish this video with an application to the midpoint formula. I'm still not done with the section. I'll finish the section next time, but I will do one more application. So I'm going to copy the statement. So this is on page 188. And I'm going to copy the graph. Okay, so the figure below depicts how a graph might indicate the increase in the revenue generated by fast food restaurants in the United States from 69.8 billion in 1990 to 195.1 billion in 2014. Use the midpoint formula and the two given points to estimate the revenue from fast food restaurants in 2002 and compare it to the actual figure of 138.3 billion. And by the way, know that note this little symbol on the on this coordinate system. This means that this is not the actual scale. They go from 0 to 60 because there's no need to write 0, 20, 40, and 60, just to indicate the values of interest. But the points are going to be, we can call them 1990, 69.8, And 2014, 195.1. Okay, so the midpoint that's going to be what? The x coordinate is going to be 1990 plus 2014 over 2. And 69.8 plus 195.1 over 2. $1990 plus 2014 is 4,004 over 2. And 69.8 plus 195.1 is 264.9 over 2. The coordinates are 2002 and 132.45. So 132. So the estimate is 132.5 billion. If we round it, the estimate is 132.5 billion dollars. So they are asking us, compare it to the actual figure of 138.3 billion. Well, this is not as close as we expected. And the reason is because real life data are not going to sit perfectly on a straight line. So most likely the points are going to be like this. And then yes, it's going to look more like that. And then they just took the first and the last value and draw a line segment, but that's not how real data works. So I will stop here, but in the next video I will finish section 2.1. Thank you for listening.